Okay, so now that we know how to find positive, negative, and zero roots, we're going to dig deeper into the imaginary roots. Let's think back for a moment to Math 2 and quadratic functions. Consider the quadratic function x squared plus 2x plus 2, whose graph is pictured to the right. Notice that the graph does not show any zeros, but since f is a quadratic, there must be two roots. So we know from practice is that if it's a quadratic, it has to equal 2, but we don't see any real roots, so the two roots must be imaginary. Find the value of the discriminant. If you're like, what is the discriminant? This is the discriminant, b squared minus 4ac. It should look familiar to you. It's the part underneath the quadratic formula. So for f of x, a is equal to 1, b is equal to 2, and c is equal to 2. So we got that from a, b, c. So we're going to find the value of the discriminant, b squared minus 4 times a times c will equal, now b is equal to 2, so b squared, 2 squared is 4, minus 4 times a is 1, times c is 2. Okay, so 2 squared is 4, minus 4 times 1 times 2 is 8, and 4 minus 8 is negative 4. What does this result tell you about the roots of f of x? So the square root of negative 4, and remember there's always a plus or minus in front of here, tells us that we're going to have two imaginary roots. So when the discriminant is negative, oops, this is the letter C, and then I need to make a negative symbol, which means less than. So when this is less than 0, we get two imaginary roots, okay? Use the quadratic formula to find the roots of f. Okay, well, we kind of already started it. X is equal to negative b plus or minus the square root of b squared minus 4ac. But didn't we already do that? We already did that, right? All over 2a, like that. X is equal to negative b plus or minus the square root of b squared minus 4ac, all over 2 times a. Okay, let's simplify this. Negative 2 plus or minus. Now, the square root of negative 4 is going to be, well, do we know the square root of 4? The square root of 4 is 2. So this is going to be plus or minus 2i over 2. Now, can this be simplified? Just, it looks like 2 divides into everything, right? So negative 1 plus or minus I. What does this mean? This means there's two answers, you guys. Negative 1 plus I and negative 1 minus I. Two answers. Okay? Since the imaginary roots come from taking the square root of negatives and using the quadratic formula, what can be said about the possible number of imaginary roots of a polynomial function? Okay, do you see how this split off into two answers? Is there any time that we'll only get one answer or that we'll get three answers? No. Okay. We will always get, so when we get imaginary roots, they're going to come in pairs, okay? They're going to, imaginary roots, they will come in pairs. And for every a plus bi, there will be an a minus bi. They're opposites, and they're also, the word for this is called conjugates. Conjugate. Everyone say conjugates. Conjugate. Okay? For this function, what are the possible number of imaginary roots? All right, this is just what we practiced before. Well, what's the power here? 4. So there could be 4 2, or 0 imaginary roots. And we actually know how to find it by finding the positives, right, and negatives. Okay, but this is just to say they come in pairs. Now you've gathered all the information needed in order to determine the possible combination of different types of roots. Draw a table below that summarizes the possibilities of type of roots for h. Then graph the function in Desmos and put a star by the combination that is correct. Okay, this is talking about h. I don't see an h. I see a p. You know what I mean? So are we going to be, let's see here. I think we're going to say that we're going to do this for p. Okay, so we're going to do our example again right here. Are you ready? Get set. Let's go. Possible number of positive roots. How do we do that? How many sign changes do we have? No, yes, yes, no. What did I say? I said yes and I said yes. So 2 or 0. Negative roots. We need to find p of negative x, which is going to be stays the same. Changes, stays the same. Changes. And for the constant, that's going to stay the same. Okay, that's our negative. So now we're going to go yes, no change, no change, yes, a change. So there could be 2 negative roots or 0 negative roots. Number of 0 roots. Is x a common factor? I always say is 0 a common factor, but is x a common factor here? None. No. None. And what do all the roots have to add up to? 4, right? So the possible number of imaginary roots are 4, 2, or 0. And if we graph that, we would see which one's the right answer based on our little chart. I don't know if I have time to graph it. I wanted to show you guys one more thing. Imaginary. Okay, so there could be 2 positives, 2 negatives, and then how many imaginary would there be? 0, right? There could be 2 positives, 0 negatives, and then 2 imaginary. There could be 0 positives, 2 negatives, and then how many imaginary would there be? 2, because they always have to add up to 4. There could be 0, 0, 0, and then how many imaginary would there be? 4. Well, that was way more exciting than our examples on the next page. Okay, everyone, turn it to this paper. What is this paper for? We're going to practice imaginary numbers a little bit. Okay, ready? Here we go. First of all, I is equal to the square root of -1. Check. Okay, if I is equal to square root of -1, what would I squared be? What would happen if you squared both sides? That's going to be -1. What about I? You're supposed to write it like cursive, like little italics, kind of. What about I cubed? I cubed is going to be -1 times the square root of 1, or -1 times I, which is -I. Just trust me on that. I to the 4. Well, what happens when you square -1? If you square -1, you get 1. Okay, and then do you guys remember this repeats? So I to the 5 is actually just I, because it's I times I to the 4. Here, do you agree with that? But what's I to the 4? 1. So it's just I. And then I to the power 6 is I squared times I to the power 4. But what's I to the power 4? 1. So I to the 6 is I squared. So it's a cycle. It repeats every 4 i's. Okay? Let's do some practice. What is this paper called? Imaginary Review. If it's not review for you, it's not hard. Okay? We do it. You could do it, learn it in a day or two. So square root of -4 is going to be 2i, What's the square root of negative 9? 3i. What's the square root of negative 100? 10i. Like that, okay? What about if you have something that needs to be simplified, like the square root of negative 20? 20 is going to be 2 times 10, 2 times 5. So the 2 gets to come out, and the negative gets to come out as an I. So we're going to have 2i, but the 5 doesn't get to come out, so the 5 stays inside. You get that? Okay. Another thing, conjugate. I already told you that. Conjugate. What's the conjugate of 3 plus 2i? 3 plus 2i, it'll be 3 minus 2i. Okay? Conjugates. Why are they called conjugates? Because watch what happens. 3 plus 2i, something magical happens. 3 minus 2i, when we multiply them. Okay? When you multiply that, we're going to FOIL this. Ready? What's 3 times 3? 9. 3 times 2i minus 6i. 2i times 3 plus 6i. 2i times negative 2i minus 4i squared. So just like with x's, you can FOIL the two together and simplify. Minus 6i plus 6i, well, what happens to those i's in the middle? They go away. But now we have negative 4. What is I squared again? Look at your little chart. Oh, well, I squared is negative 1. Cool. So we get to replace this I squared with a negative 1 here. Okay. So we have 9 plus 4, because negative 4 times negative 1 is positive, and so this is equal to 13. What? Okay, so what's the big idea? The big idea, when you multiply by the conjugate, how do you spell multiply? Got it. Check. When you multiply by the conjugate, I hope the sound's working on this video. It'll be a big waste of my afternoon. When you multiply by the conjugate, the i's go away. Isn't that exciting? So exciting. Let's do another one. You want to make it up? We can't really do that because we're on a video. So let's make it up. Let's do 5 minus, I don't know, 8i. Okay, if we have 5 minus 8i, what would the conjugate be? 5 plus 8i. The conjugate just means the same terms with a different sign. You guys know it is a difference of two squares pattern. A plus b, a minus b. Yeah? Okay, let's multiply this out. Distribute. 5 times 5, 25. 5 times 8i. What's 5 times 8? 40i. Negative 8i times 5 minus 40i. So those will cancel. Negative 8i times 8i minus 8 times 8, 64. I times I is I squared. Okay. What happens to the i's in the middle? They cancel. So we have 25 minus 64. Every time you see I squared, you guys, I squared is equal to negative 1. You change it, okay? So I squared becomes negative 1, and we have 25 plus 64, and that adds up to, oh my goodness, I am tired. There we go. Da 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 da. Okay, just a review of imaginary numbers. Hope that was helpful.